Hey everyone, welcome back to my YouTube channel. This is Anusha. If you haven't liked my last videos, please do like and subscribe to my YouTube channel. Today, my topic is how eye works as a camera. So, in this video, I'll be covering you guys about eye comparison with the camera and the features of camera regarding eye. So, let's get into the presentation, guys. Introduction. There are many similarities between the human eye and a camera, including a diaphragm to control the amount of light that gets through to the lens. This is to shutter in a camera and pupil. At the center of the iris in the human eye, a lens to focus the light and the camera to create an image. The image is real and inverted, a method of sensing the image in a camera, and the film is used to record the image in the eye. The image is focused on the retina, and a system of rods and cones is the front end of an image processing system that converts the image to electrical impulses and sends the information along the optic nerve to the brain. The way the eye focuses light is interesting because most of the refraction that takes place is not done by the lens itself but by the aqueous humor, a liquid on the top of the lens. Light is refracted when it comes into the eye by this liquid, refracted little more by the lens, and then bit more by the vitreous humor, the jelly-like substance that fills the space between the lens and the retina. Comparison of human eye with a photographic camera. The human eye and the camera both have convex lens which form real and inverted image. Eye is iris and the camera's aperture both possesses the amount of light and both change depending on the lighting conditions. Both eye and camera focus on a single object and on the large images and capture the large scapes. The cornea of the eye is very similar to the lens of a camera. Both sit and the front of the body are both transparent and have a spherical curvature. Camera and eye both capable of viewing different tones of gray and various shades of colors and also capable of sensing near and far, judging the size of different things, registering depth and capturing the moments. The cornea is comparable to the lens cover of the camera, as the cornea is the cap of the eye, is transparent in nature and sits at the front of the eye, and as a spherical curvature, it covers iris, pupil, and anterior chamber, and provides most of an eye optical power. The lens of the camera is also transparent and sits at the front of the camera body and maintains a spherical curvature. Iris is comparable to the aperture of the camera as aperture controls the amount of light entering the camera. Similarly, iris controls how much light enters the eye by changing the size of the pupil. This is similar to what happens when a camera captures an image. First, light hits the surface of the camera's lens. The aperture controls how much light enters the camera. Then the light makes its way to light sensitive surface for the long time. This surface was the camera's film. In today's digital cameras, this surface is an imaging sensitive. How does an eye focus differently than a camera? The lenses in your eyes change the shape to stay focused on moving object. The thickness of the lens also changes to accommodate the image being viewed. It is able to do this because the lens is attached to small muscles that contract and relax. As a camera can't do this, that's why photographers change lenses depending on the how far away they are from the object. Mechanical parts of the camera lens also adjust to stay focused on a moving object. How does an eye process color differently from a camera? Your retinas contain two types of photoreceptors, rods and cones. Rods allow you to see the low light. They aren't useful for color vision. Cones let you to see the color. There are three different types of cones. Each type responds to different wavelengths of light. Red cones respond to long wavelengths, blue cones respond to short wavelengths, green cones respond to medium wavelengths. Resolution and sensitivity. The human eye is an incredibly complex and high resolution organ capable of perceiving a wide range of colors and details. It surpasses most commercial cameras in terms of dynamic range, sensitivity to light, and resolution. Field and view. The human eye has a wide field of view, allowing us to see a large area without needing to physically move our eye. This is different from many cameras, which may have fixed or adjustable fields of view. Depth perception. The human eye has the ability to perceive depth, which is crucial for understanding the spatial relationships between objects in our environment. Cameras use various techniques such as stereo vision to replicate this, but it's not as sophisticated as the human eye. Adaptation and focus. The human eye can adopt two different lighting conditions, adjusting its sensitivity to light. It also has a remarkable ability to focus on objects at different distances. Cameras often struggle with the rapid transitions from the bright to dark environments. Feature technologies. There is ongoing research and development in the field of vision enhancement and artificial vision. This includes technologies like bionic eyes, which are designed to restore our augment vision in individuals and visual impairments. Ethical and physiological considerations. Discussions about enhancing human vision through technology raise ethical questions about privacy, accessibility, and potential for creating disparities between those who can afford such enhancements and those who cannot. Thank you for watching my video. Please do subscribe to my YouTube channel.